when we talk about a quadratic, we're talking about something that generally will have some squared term in it, alright? And generally when we talk about a quadratic, you'll see something looking like this. So this is a quadratic expression, alright? So yes, it could have just ax squared by itself, and that is a quadratic expression. It could have just x squared. It could have ax squared plus bx. It could be ax squared plus bx plus c. The important thing to note is that once you see this x squared or y squared or m squared or anything squared, right, any variable squared, you are dealing with a quadratic expression. Alright, so that's what she was trying to explain in her own words, what she meant by a quadratic. Alright, so this is what a quadratic expression looks like. And when we talk about solving quadratics, there are multiple methods of solving quadratics, but some of the ones that we looked at last term in particular, we looked at two methods. We looked at one method which involves factorization, right, the factorization method. And then we looked at another one which involved a cumbersome looking type of formula called the quadratic formula. Those two methods you would use more regularly than the completion of squares form. The completion of squares form is another way of solving quadratics, which we will be looking at. I'll check and see if it's this term. But yeah, you will learn how to do completion of squares. And one of the things that I do like about that particular form of the quadratic is that, one, you can actually identify the properties of your quadratic function. If you could recall properties of quadratic functions from term 1, you can identify it from that form, as well as you can use it to solve the quadratic and get the values of x, which will give us the quadratic being equal to 0. And that particular form is quite useful for many things, so that's why we will be looking at it a bit later on. But before we get into all that wonderful stuff, we definitely need to recap what we do know. Alright, so the first thing that I want to do is look at this expression. Alright, so I'm going to put a few expressions, and I don't know how many people might recall from last term the types of quadratic expressions, but we'll find out, shall we? Alright, so that's one quadratic expression. Another quadratic expression. Let's see if we'll locate another one. So I have three different quadratics here. Anybody could tell me if they recognize any of these quadratics as being termed something specific, like there's a name for it? Anybody could recall anything of this sort? This one? Yeah, like, do you recall within quadratics we talked about some quadratics that have a very specific form, and based on recognizing those forms it might make your life a little bit easier to do factorization, maybe? It has something to do with square. It has something to do with square. Alright, so you recalled one of the terms, perfect square. calling another name. So do you think that's a perfect square? So how many people agree that that's the perfect square? Raise your hand. I'm checking. How many people agree that's the perfect square? Look, Aliyah, have some faith in you. My goodness. No. I just want to know if you recognize the forms. Okay. So, okay. I'm gonna put something else on the board now. Let me just erase this arrow. So perfect square, just keep it in mind. It's something to, make notes of. Okay, what is this? X squared is a squared term. Is 25 a squared number? Okay. And when we subtract, what are we doing? There you go. So this one is called the difference of two squares, because you are finding the difference of two squares, two square terms. So that's where that comes from, right? So just to clear up your mind, difference of two squares. And the one that you call the perfect square, the perfect square is actually this guy way up top here. And why is this one the perfect square? Well, when we express it in its factorized form, you'll see why, and it might be able to stick with you at that point. But there's also a way that you could analyze the quadratic itself like this to determine whether or not it is a perfect square. Well, first of all, your first term must be a squared term, so it's like x squared, right? We'll come back to the middle term in a little bit. Is 16 also a square term? So if 16 is a square term, how would we write it as a number squared? What number squared? 4 squared, 4 to the power of 2. Now, look at something. This middle term, do you agree with me that I could write it as 2 times 4 times x? Eight is the product of 2 by 4. 8 is the product of 2 by 4. That's what I'm asking. The coefficient can it be broken down into being a product of 2 and 4? Yeah. So what this is showing you here, alright, the perfect square, you'll have a perfectly squared x term, a perfectly squared constant, and your middle term is going to be twice the product of the square root of the first and the last term. So this is the reason for asking, can I write 8 as 2 times 4? And well, because it's x, an x term, 2 times 4 times x. So this is 4 being the square root of 16 and x being the square root of x. Okay, so that's one way that you could do it. You don't necessarily, like I will always say, you don't have to know how to do that, because factorization, the method that we learned, can be applied to absolutely any quadratic and you'll be able to factorize it. So the perfect square, when we factorize this completely, what we'd actually get is something that looks like this: x plus 4 squared, right? So when we talk about a perfect square, we're talking about a repeated binomial factor, and that's why we could write it like this. And the difference of two squares, on the other hand, would be something like this. It's the same numerical value, like x plus 5, so same terms but different signs. Alright, so this is a difference of two squares factorized, and this is the perfect square factorized. Okay, so let me see how much time I have. 7 minutes. Okay, so here's what we're going to do. We're going to recap how to do the factorization with the 3x squared plus 13x minus 10. Because we're doing recordings here, I'll put it up so you'll have it to go over and practice using the factorization technique on the other two expressions. Alright, so let's talk about factorizing 3x squared plus 13x minus 10. How do we begin the process of factorization? What's the first thing that we do when we want to factorize any quadratic expression? Anybody want to tell me what's the first thing you need to do if you're going to factorize? Lovely. Let's identify A, B, and C. So where do we get A, B, and C from? Anybody? There we go. Coefficients. So, what does Jaden have to say? Coefficients as well. Lovely. So yes, let's talk about the coefficients. Can you tell me? Wow, such a coincidence. I'll line it up already, watch. The coefficient of x squared is A. The coefficient of x is B. And your constant is C. So, oops, did I do that? Alright, from here now, let's write down what A is. So A is positive 3, B is positive 13, C is minus 10. We all agree? So I have one yes so far. We all A-okay with that? Okay, lovely. Just checking. Need to make sure that everybody on the same page. Right. Okay. Now, if it is, I want to do my factorization process, what must I do from here? Alright, so let's see. Okay, so Anya says, right, even Jaden agrees. You're going to find the product of A and C. So let's start by doing that. Yes, even Ronald. So you see, it bringing back some memories, man. Bringing back some memories. So AC, product of A by C, will give me minus 30. Alright, 3 by minus 10 is minus 30. What do we do from here now? There we go. And not just the 30, but minus 30. Alright? So yes, we're looking at a pair of factors of minus 30. When we multiply it, we're going to get a minus 30. But when we add them together, we have to get a positive 13. Positive 13. Okay, so again, directed numbers here is going to be very important. So anybody want to tell me some pairs of factors of 30? So we're going to look at it from that perspective first. Pairs of factors of 30. Alright, let me start off. A pair of factors would be 1 by 30. Any other factors you could think of? Alright, 5 by 6. Anybody else want to tell me a pair of factors? 3 by 10, very good. Let me see what Renell says. Ronell says 10 by 3. Alright, yeah, same thing. Anything else? Did we miss any? Ah, lovely. 2 by 15. Okay. So, now that we have, I think we have all possible pairs of factors, right? Let's start thinking about it the way Anya explained to us. We need to find a pair of factors that's going to give us minus 30, but at the same time, if I add them together, I have to get a positive 13. So, all of these I know when I multiply them, I could get a 30 as the result. But, there we go, lovely. Raquel has the answer for us. So Raquel says we're going to use this pair of factors here. We're going to be using the 2 by 15. Because when I multiply 2 by 15, I could get 30. Now, one of these numbers has to be negative, simply because my answer here is a negative number. And the number that has to be negative, right? I know I'm using a 2 by 15. So 2 plus 15. Now, as it is, 2 plus 15 is going to give me 17. I want to get a positive 13. If my result is positive, that means my larger number has to be positive. So this is the reason why 2 is going to be negative. So I have a negative 2. Negative 2 by positive 15 is going to give me the negative 30 I want. And negative 2 plus 15 is going to give me the positive 13. So they both, in both scenarios, they work out well for us. So now all I have to do from here, okay, if we use 3 by 10, let's look at it like that, right? So 3 by 10, it could give us 30. But remember, we want to get a negative 30. So which number you'll put as the negative? Right? That's it. That's it. That's the reason why. You'll get 13 only if they were both positive, right? So 3 by 10, giving you a positive 30, and then 3 plus 10 is positive 13. That's the only way you would get that 13. So this is the reason why we can't use it 3 by 10. We'd use it 3 by 10 if you wanted positive numbers only, and you wanted to get a positive 13. Alright? So, Anya, makes sense why we use the 2 by 15 versus the 3 by 10? Alright, nice. Oh, could it be the other way around, like 15 in minus 2 place? And yeah, so you don't have to write it the same exact way that I write it, as long as you know, one, in this case, the multiplication here is commutative, so you'll still get the minus 30. And here with addition as well, it's commutative. So you would get, if you write 15 plus the negative 2, you're still going to get a positive 13. So the order in which I wrote them, it won't affect you. Even when you have to do the next part of the factorization, I have over time. Okay, so here's what we're going to do. From here now, I don't know how many people recall what is the next step, but your next step is to break up your middle term into the sum of minus 2x and positive 15x. And then from there you do your factorization by grouping. Alright? Yes? Yes, I did. So like I said, I would put it up for you all. So from here now, like I said, I don't know how many people recall the process properly, but go over your stuff. And what I'll do, I'll just go through the steps here to give you all the final answer. And if you all have any questions about it, like I was saying, do some review work. And when we meet again on Thursday, we could brush up on whatever you will need to get some clarity on. Alright? So this will be my final answer. And this particular quadratic is just, a regular quadratic, not a perfect square, not a difference of two squares, simply because the binomial factors are just like that. Say that back. The first bracket wasn't supposed to be no, you remember. Okay, so like I said, go back over the process. Over here, what you're supposed to do is factor out the highest common factor. So you're going to factor out x from 3x squared and minus 2x, and that's why we have x open bracket 3x minus 2. So like I said, if you have any questions about doing your factorization process, go over your stuff from last term with factorization. When we meet on Thursday, you all could go through the questions, and that we were talking about to do with quadratics, and we'll get some more clarity on whatever you'll need to brush up on. Alright?